Hi, my name is Megha Patel, and I'm representing the CS10 final project created by myself, Sunny and Nathaniel. For this project, we created a snake AI game that functions like a standard snake game, but with the computer playing the game on its own, while the user hangs loose and watches. Let's take a look at our game on Pygame. So this game functions so that the snake travels around the board directionally in order to reach the apple. When the snake eats the apple, it grows in length. The snake is not allowed to hit the edges of the board as well as its own body, otherwise it will die. The goal of the game is to get the snake the longest it can get without dying. In this game, the snake will move by itself rather than the standard game where the user controls the snake's movement. This project uses Python 3.6 as well as a Pygame module. So let's continue to look at this game before we dive into the code. So now let's take a look at the code. So the basic game, the code is separated into two parts, the basic game function and the AI function. The basic game function can be divided into two portions, the initializing portion and the basic functioning portion. So in the initialized portion, we initialize the game data, the game board, and the snake. The game data sets up the board parameters, like the height and the width. It uploads images we use for the snake and the apple. It establishes the first position of the apple. And it sets up empty lists for the snake and the visual snake. These variables will contain the coordinates of which the snake occupies. This is especially important because it will keep track of where the snake is so that the snake will not hit itself. These are empty in the beginning because the snake has not yet been added to the board. When the game board is initialized, it opens up and sets up Pygame. And then we have our basic functioning portion. This portion of our code adds the snake to the board with the initial length of 3 in a given location. It also adds the apple into a random coordinate on the board, but it also has to make sure that the apple is not added to its space where the snake already occupies. The code then proceeds to enforce only legal moves by ending the game if the snake hits the edges of the board or its own body. Next, we have the AI portion. So in the AI portion in our code, we're going to be using breadth first search to search for the most efficient way for the snake to reach the apple. In our code, breadth first search will be used to find the shortest path from the starting node, the head of the snake, to the target node, the apple. But in order to do that, we created a function which expands the nodes, which adds +1 and -1 to individual items of the coordinate to explore the children nodes. Our code also takes into consideration whether or not a child node is a legal spot for the snake to go by checking whether or not that node is in snake list or beyond the board parameters. These paths are a list of all the coordinates that the snake could possibly move to reach that food. It uses these possibilities and returns the shortest list of coordinates. So the pseudocode of this algorithm works by basically we create a list for the frontier using the initial state of the problem. We add the starting node or the head coordinate, and then we create and set a list of all the nodes that we already explored to be empty, so this prevents searching through nodes that have already been searched, thus avoiding an infinite loop. So it's the algorithm will stop when the game queue is empty. So in order to continue to search through, we set the current position to the position of the head. For each item of the children of the starting node, if the first item of the frontier, the head, equals to the target, we return the shortest path. If not, in the export set, if the node is not in the export set, we add the node to the export set and then we expand the node using the expanded node function. So that is essentially our game. I hope you enjoyed it. We certainly enjoyed creating it. Thank you for watching.